Okay, so we're doing, this unit is about proving quadrilaterals, but it's not the two-column proofs that you saw last fall. It's showing, it's more algebra stuff, like showing, hey, can we show that diagonals bisect each other? That's one of the properties of parallelograms. Can we show both pairs of opposite sides are parallel? Can we show that opposite sides are equal? Can we show one pair of sides is parallel and equal? So those are 4 different methods. Any one of these methods is enough to prove it. For notes, we're going to go through all the methods. When you get to project to the end of the unit, you don't have to use every single method. You just have to make sure you have enough to prove it. So first step is plot, so -2 and 3, 4 and 3, do -2, and -4 to -2. And then connect it if you haven't yet. Okay, so our method 1 is show that the diagonals bisect each other by showing midpoint of the diagonals. How would I find midpoint of the diagonals? What do we use when we're finding midpoint? Okay. You got it, yeah. So our midpoint formula. So method 1. So we just use midpoint formula, which is add our x's, divide by 2, add the y's, divide by 2. And so my diagonals, which 2 letters would make the diagonals in here? Which sets of letters? Yeah, so ln is one of them. And then mo. And so ln, so I'm going to plug in my -2 plus 2, divide by 2, and then my 3 plus -2, divide by 2, and I get 0 and 1/2. Alright, so and then m and o, so 4 plus -4, divide by 2, and 3 plus -2, divide by 2, came back to the same 0 and 1/2. That's easy, right? Just plug in the points in the midpoint formula. Okay, so now the next 3 all deal with slope and distance. So we're going to go ahead and just make ourselves a little chart here for slope, distance, and then we'll be doing it of all 4 sides. So LM, MN, NO, and OL. And you can go ahead and draw the lines and make a chart. You can just write them out in order, whichever is easier for you. So what is the slope of LM? What do we call it when it's a horizontal line? 0, right? Okay, that means distance is really easy. What's the distance of LM? We just count it, right? So distance is 6. Am I going too fast? A little fast? All right, who can count out the slope for MN? 5/2. Positive or negative? Positive. And so if slope's not something really easy for you, I always do counting like this. Count down 5, back 2. Makes it positive. And so then distance for this one, we have to either use Pythagorean theorem or a distance formula. How many of you prefer Pythagorean theorem? How many of you prefer distance formula? Okay, so we're split half and half. This very first one, I'm going to show you just both ways. So we've already counted out 5 over 2, which means my distance is just going to be, if I'm using Pythagorean theorem, it's just 5 squared plus 2 squared, and I take the square root of it. And so that becomes 25 plus 4, and so my distance is just square root of 29, because 29 doesn't simplify. If I plugged it into the whole distance formula, I would just go back to my original points and do my 2 minus 4 squared plus negative 2 minus 3 squared. And so that becomes negative 2 squared, negative 5 squared, which is exactly the same thing. So it's completely up to you what you use. If you're going to, in anything you do in this, you already have them graphed and already have counted the slope, so it's really easy to plug into Pythagorean theorem. If you feel like you make mistakes counting things on the graph, you can plug the points in to distance formula this way. All right, NO, what's our slope?
No.
No? Okay, for no, what is our slope? 0 again, right? Okay, and what's the distance?
6.
6 again. For OL, what's our slope? 5 over 2 again. What's our distance? Square root of 29. Okay, and then now what we have to do is write our proof statements. Okay, so we now have the evidence to back it up, but we just have to come back up here and write our proof statements. So our proof statements would be Ln is congruent, Ln midpoint equals MO midpoint for that first one. And then I'm going to go ahead and list out their 0 and half. This is a part of notes I recommend you taking real exactly, because on your test at the end of class you'll have to write out statements like this. So just make sure you know how to write the final statement once you've done the math. Okay, both pairs are of opposite sides or parallel, so they have equal slopes. So I take my opposite sides and write LM is parallel, I just use my parallel symbol, to NO, and I'm going to put my slope there just to show that's my evidence that they're parallel. They both have a slope of 0. And then MN is parallel to OL. They both have a slope of 5 over 2. So the proof statement is just telling me what I've proved and then what that slope is. And then for the method 3 here, it's the same thing, just with congruent. So LM is congruent to NO. Their distance is 6. MN is congruent to NO. Their distance is square root of 29. Wait, say that once more. It is totally LO. Thank you. All right, and then the last one, method 4, is just show one pair of sides is both parallel and equal. So instead of writing out the statements this way, I could choose just to write LM is parallel to NO with a slope of 0, and LM is also congruent to NO with a distance of 6. Or I could do with the other two. So the proof statement has to be at least one of those with the evidence. Alright, are you ready for the next one? So go ahead and plot it if you're finished with these notes.
So we just did the first one. That's all for one thing.
It's all for one thing.
We have to do a performance because we're going to take the one.
When you get to your project, you'll just have to do one. It'll have really clear directions. I think part of the part of the project is like finding the slope and distance, and then just writing out your proof statement based on that.
Oh, no, how much if you do one?
We'll look at the directions when we get there. Can I move my paper up? Y'all finished with that? Okay, so GHI is 4 and 5. And O03. Okay, so this is a rectangle. And so for rectangle, we have to find the slope and distance. We have to prove it's a parallelogram first, and then we show diagonals are congruent, or we show that it has a right angle using slope. So what we're going to do with all of these, we're going to go ahead and just find our slope and distance, which is enough to prove parallelogram and prove our method 2 here. So let's, as quickly as possible, find our slopes and distance. All right, who can tell me, if we count out, what's the slope of GH? You're still plotting. So up 2 over 4. So 2 over 4 reduces to 1/2. All right. How about IH? What's the slope of IH? Doing your view slope or so I to H -2, right? Okay, so this one was up 2 over 4. I'm drawing it out because then we can do Pythagorean theorem real easily. I and H is up 2 back 1. So it becomes -2. IO, is it the same 1/2 slope?
Yeah.
Okay, so did I write it wrong? Oh my goodness. She was supposed to stop me at the beginning if I make a mistake like this.
We're not supposed to make mistakes.
Why did I decide to make it? Oh, I'm supposed to make mistakes so that you can catch my mistakes. All right, that's supposed to be a J, not an O. I think I looked at the 0 and thought it was an O. Okay, IJ, what's our slope of IJ?
I have a question.
All right, let's finish this and then ask me your question. Okay. I heard someone say it again. It's 1/2 again, right? So the up 2 over 4. And then JG, what is our slope?
-2.
-2, okay? And then distance, we can't count any of these straight, so we just need to do distance formula. So distance formula or the Pythagorean theorem. So G and H I already counted, so it's just going to be 4 squared plus 2 squared equals square root of 20. Does square root of 20 simplify?
Yeah.
Mm-hmm. So if we can draw it out into, yeah, 5 and 4, and then 4 is that perfect square that goes to 2 and 2, and so it becomes 2 root 5.
What the?
You remember simplifying, right? We just factor it out till we find our perfect square, or we found our doubles. You have to simplify, yes. to get full credit, you have to simplify. All right, the next one's even easier. 2 squared plus 1 squared. What's that give us? 2 squared is 4. 1. So square root of 5. Can we simplify square root of 5? No. And because I've already counted out, this is the same 4 and 2, so I know that's going to become the same square root of 20 to root 5. Because I've already counted out, this is 2 and 1, it's going to become the same root 5. Okay, so now I have enough to prove it's a parallelogram, and so I can choose any 3 methods. So I have enough to prove methods 2, 3, and 4. Which one should I use?
I just need 1 and 2.
Okay, so this is really important. Highlight, circle, something. We have to prove that it is a parallelogram first. So if we're a rectangle, basically, if you look back at the chart here, every level in it means you have to have an extra proof. So because a rectangle is a type of parallelogram, we have to prove parallelogram and then rectangle. If we get to rhombus, same thing. Rhombus will have to prove parallelogram and then rhombus. We have to have at least 1 proof per level. If it's a square, we have to have at least 3 proof statements because we have to prove parallelogram, rectangle, and square. Okay? So rectangle, we have to have 2 proofs. So I have to choose, so I have these options. So I have to prove level 1 parallelogram first. So what statement should I use to prove it's a parallelogram? So I could use any of these 3 statements, right? Because I've already figured those out. Okay, that's a lot of confused looks. Okay, so how do we know that this shape is a parallelogram? What do you think? Looking at this shape, how do you know it's a parallelogram?
Look at it.
Opposite sides, there's 4 sides, opposite sides are parallel. Okay, so all I need is a statement saying opposite sides are parallel. And so I'm going to say JI is parallel to GH. And I found this, I have the proof because I have both of them have a slope of 1/2. And then HI is also parallel to JG.
Oh, I see what to do now.
Because they have the slope of -2. So all I have to do to prove rectangle, I have to prove it's a parallelogram. So with any of the 4 options to prove it's a parallelogram, I pick one. And then I prove it's a rectangle by one of these 2 methods. So I have to have the proof statement for parallelogram. I have to have proof statement for rectangle. Because these are notes, we're going to go through both methods, but you have to have at least one. So I have enough already for method 2. Show it has a right angle by using slope. How do we know that these are right angles? Yeah, we know opposite reciprocal slopes give us right angles. So I'm going to write GH is perpendicular to HI. And that's because they have slopes of 1/2 and -2. And because this is notes, we're going to do the diagonals also. So diagonals congruent, is congruent talking about distance or slope or midpoint? Distance. So when we see the word congruent, we're talking about length. We're talking about the measure of something. And so I'm just going to do the diagonals. And so what 2 letters are my diagonal lines?
G and I.
So G and I. And then my other diagonal would be JH. And so these ones, we could either plot them out or see if we can count them on there, or we can plug into distance formula. GI, I'm going to choose distance formula. So that would be our 4 minus 1 squared plus 5 minus 1 squared. And so you can plug that into your calculator. You can do the math by hand. So 3 squared plus 4 squared comes out to square root of 25. Do we know the answer to square root of 25? So our distance is 5. Okay, JH. Can we count that easily on the graph?
No. Yes.
Yeah, that one just happens. They both have they're both at 2. So 1, 2, 3, 4, 5. That's a straight line we can count. So we just count it out. Okay, so then my statement is just JI is congruent to JH. Both of them have a distance of 5. So that's our method 2. So for each shape, you can choose which method you use to write your proof statement, but just remember for a rectangle, you have to have 2 levels, a parallelogram level and a rectangle level.
Correct. Wait, so we have to do 7 and 8?
Okay, so we're scheduled to also do 7 and then do assignment page 11 and 12. I think we're going to pause here. Let me go ahead and pause the recording.